Yeah, it should be working. Yeah, now it's a bit. Yeah, OBS is playing up a bit. That's okay. Well, because it's free, so we shouldn't be complaining. Have to always make sure the microphone on the webcam is not actually being used. Okay, so we're doing another live session, development session, feedback session. We are working on enhancing biomedical data analysis tools and dashboards. We'll be implementing new features, maybe, hopefully, addressing any feedback that you might have, and happy to also discuss latest data visualization and signal processing techniques. I'm trying not to cover any news or anything like that, don't like it, but any more established techniques we're more than happy to learn about. Your input is super duper valuable. And yes, full disclaimer, we're using GPT, ChatGPT, and the likes for development, all the text, social media posts, and the like. So beware. The robots are coming. Just trying to generate the social media post. Just copy pasting. Copy pasting is a skill, isn't it? Bionichaos is innovative platform dedicated to democratizing access to advanced biomedical data analysis. More or less correct. It offers interactive tools and dashboards for processing complex biomedical data, covering topics like statistics, neural networks, fuzzy logic, and more. Yes, could expand on that, but okay. Yeah, we're diving deep into development most of the time. Yeah, we'll be, if something is obviously handy, we will be deploying. Well, pretty much can deploy straight away. Yeah, whether you are a seasoned data scientist or just curious about biomedical data, there is something for everyone. You can support us on Patreon as well. I'm just trying to get the link for it. Oops, there are ads. Yeah, the ads should not appear in the first page. I have to fix. Well, sometimes if your screen is narrow, then well, it actually would not be appearing on the front page. Yeah, I was looking for this one. Yeah, LinkedIn. It like links that are above whatever it is, 26 characters or something crazy like that. And I really don't like when it's changing my links. Don't appreciate that at all. Not even sure why it does that. So even a Patreon or so, it's yeah, it's doing something to the link. Just yep, should be okay. And yeah, and if you so tools like this, if you don't want to use your camera or something, with people concerned with privacy, there's probably a really good reason for that. Well, I don't know, it doesn't matter how many times I say it, but for these tools that I have on the website, when the camera is being used, it's not actually being sent to the server, like your face. I don't need your face on my server for sure. So I'm not, so the video is not being uploaded, there's nothing recorded. All the processing is happening on your browser. But yeah, it's like, doesn't matter how many times I would say it. Yeah, fair enough. Don't trust that. So yeah, if you don't want to give permission for the video, you can see a video of me using it. I sacrifice, volunteer my face. Yes, let's yeah, post. Can do this social media posts forever. Keep modifying them and adjusting. Doesn't actually make them better, does it? Yeah, I'm having issues with my volume as well. I have to be close to the microphone or something. I need it in the yellow. Yeah, hopefully this is better, but I keep moving around, so sorry if the sound is eventually when editing videos I'm trying to adjust the sound so it's all consistent, it's all the same across the video, but it doesn't necessarily always work, so bear with me. Okay, and we'll be essentially jumping into one of those, developing them further. We have a bunch that let's open our development suite. Yeah, we're using Visual Studio Code. Don't really care about that. Yes, we editing videos. Yeah, we have a huge backlog. By the way, if you are into editing videos and you would like to help, do let me know. Yeah, we have this automated script that is removing silent bits from live streams when I'm not talking or doing something else. But still requires quite a lot of editing. So we are currently, yeah, editing a video back from May. So yeah, if you've seen the live stream and there's not much happening, yes, they are normally reduced from like 3-4 hours down to 20 minutes or so. But it requires some time. Okay, so we have this XML for the page. This will be everything we are working on. Yeah, we should have some sort of random number generator to essentially decide which tool we are jumping in, unless you have comments or questions on one or any of those, I'm more than happy to cover that. How many currently? Yes, we have 66 links in there. Why do I have a feeling? Yeah, we removed a bunch that were in the works but were abandoned. There's still some that return an error. There's 4 that return an error. That's not good, is it? Push this long term. Yeah, let's go into long-term EEG. We'll actually open it in another video. The reason in another video, in another window. Long-term EEG, open folder. Well, right. Well, no wonder it doesn't work. It doesn't actually have HTML. That's not good, is it? I'm doing something a bit bad as well. Yeah, we are interested in ultra long-term epilepsy monitoring, EEG. Yeah, must have been comparing bot to ChatGPT. For now, well, it doesn't really. That doesn't really matter. We might rewrite the text. So start a new GPT-4 note. It doesn't seem to time out that much. And let's see what it generates straight away out of the box. But yes, we'll need a probably don't actually need to open it in a separate file. Yeah, I'll have an index HTML there. And let's actually read what the robot got to say about this. It's like I actually need my audio from the desktop to be turned on.
An ultra-long-term epilepsy monitor, ULTEAM, represents a significant advancement in epilepsy management and treatment. These monitors involve continuous subscalp EEG, electroencephalogram monitoring over an extended period, from months to years. This technology offers several potential benefits for epilepsy patients and healthcare providers. 1. Improved seizure detection. Traditional EEG monitoring is limited to short sessions in clinical settings, often missing infrequent or unpredictable seizures. UL teams provide continuous data, enabling healthcare professionals to detect seizures more accurately and comprehensively. This leads to a better understanding of a patient's seizure activity and patterns. 2. Personalized treatment plans. With access to extensive long-term EEG data, healthcare providers can develop personalized treatment plans tailored to individual patient needs. This can result in better seizure control and an improved quality of life for those with epilepsy. 3. Reduced hospitalization and office visits. Ultra long-term monitoring can reduce the need for frequent hospitalizations or office visits. This is particularly beneficial for patients living far from healthcare facilities or those preferring the convenience of at-home monitoring. 4. Data for research and development. The vast amount of data collected from UL teams can be invaluable for epilepsy research. It can lead to a better understanding of seizure patterns, triggers, and potential innovations in treatment and management. 5. Early intervention. Timely detection of seizures enables early intervention. Healthcare providers can adjust medications, recommend lifestyle changes, or explore other treatment options promptly, potentially preventing severe complications. 6. Remote monitoring. ULTEAM data can be transmitted remotely to healthcare providers, enhancing their ability to make real-time decisions and adjustments to a patient's treatment plan. This remote capability ensures continuous patient support, regardless of location. 7. Quality of life improvements. By providing accurate and continuous assessments of a patient's epilepsy, ULTEAMs can improve the overall quality of life. Patients gain confidence in managing their condition, knowing they are being closely monitored. 8. Seizure pattern analysis. ULTEAMs can be trained to identify specific brain activity patterns associated with seizures. This could lead to earlier and more effective seizure detection and treatment, as these patterns might not be visible with traditional EEG monitoring. UL teams are still under development, and their effectiveness and widespread adoption will depend on factors such as cost, patient comfort, data management, and regulatory approval. However, if successfully implemented, they could significantly advance epilepsy management and treatment, benefiting both patients and healthcare providers. This technology holds the promise of transforming epilepsy care by providing continuous, accurate monitoring and enabling more informed treatment decisions.
Okay, let's comment on this and we will continue developing. So eventually we want to turn it into a blog, but even better, we would like to turn it into a Flask web application, but we are not doing any coding yet. We need to cover the basics, so make the blog complete and devise some options for what the web application will be look like, what's more important, what kind of data sets we might be using for this. So if you can generate continuous paragraphs and avoid dot points, that will be appreciated. Don't mind you going into technical details, but keep it fun. We are live streaming on YouTube.
Sure, let's dive deeper into the topic of ultra long-term epilepsy monitors, EAMs, and flesh out the blog with more detailed content. We'll also brainstorm ideas for a web application, discussing potential datasets and features that could enhance the experience for users. Let's start by expanding the blog post, keeping it informative and engaging. Ultra long-term epilepsy monitors, a revolution in epilepsy management. Epilepsy is a neurological disorder characterized by recurrent, unprovoked seizures. Traditional methods of monitoring and managing epilepsy often fall short, primarily due to the intermittent nature of seizures and the limitations of short-term clinical EEG monitoring. However, the advent of ultra-long-term epilepsy monitors, ULTMs, promises to revolutionize epilepsy management by offering continuous subscalp EEG monitoring over extended periods, from months to years. Ultra long-term epilepsy monitors provide a comprehensive view of a patient's brain activity, far surpassing the capabilities of traditional EEG sessions limited to a few days in a clinical setting. By continuously recording electrical signals from the brain, these devices can detect seizures that occur infrequently or unpredictably, providing healthcare professionals with more accurate and comprehensive data. This continuous data stream enables a more nuanced understanding of a patient's seizure patterns, potentially revealing triggers and patterns that were previously undetectable. The wealth of data gathered by ULTMs allows for the development of highly personalized treatment plans. With long-term insights into an individual's seizure activity, healthcare providers can tailor treatment strategies to better control seizures and improve the patient's overall quality of life. This personalized approach is a significant step forward in epilepsy care, moving away from one-size-fits-all treatments and towards precision medicine. Moreover, ULTMs have the potential to reduce the need for frequent hospital visits. Patients can benefit from continuous monitoring in the comfort of their homes, reducing the stress and inconvenience associated with regular clinical visits. For those living in remote areas or with limited access to healthcare facilities, this technology is particularly beneficial, offering a level of care and monitoring previously unattainable. The continuous data collection by ULTMs also contributes to epilepsy research. Researchers can analyze vast data sets to uncover new insights into seizure patterns, potential triggers, and the overall mechanisms of epilepsy. This information can drive innovations in treatment and management, paving the way for new therapeutic approaches and possibly even preventative strategies. Timely detection of seizures is another critical advantage of ULTMs. By identifying seizures as they happen, healthcare providers can intervene early, adjusting medications or recommending lifestyle changes to prevent further complications. The ability to remotely transmit data to healthcare providers enhances this benefit, allowing real-time monitoring and immediate response, no matter where the patient is located. Improving the quality of life for epilepsy patients is at the heart of ULTM technology. Continuous and accurate monitoring provides patients with peace of mind, knowing that their condition is being closely watched. This assurance can significantly reduce anxiety and improve overall well-being, allowing patients to live more confidently and independently. As we explore the potential applications of ULTMs, it's essential to consider the development of supportive technologies, such as web applications that can facilitate the use of these monitors. Imagine a Flask-based web application designed to complement ULTMs, providing a seamless interface for patients and healthcare providers to access and analyze EEG data. This application could offer real-time alerts, data visualization tools, and personalized treatment recommendations, all while ensuring user-friendly navigation and accessibility. Concept for a web application. Developing a web application to support ULTMs involves several key components. Firstly, the application should provide a secure platform for storing and accessing EEG data. Given the sensitive nature of medical information, robust data encryption and privacy measures are paramount. The user interface should be intuitive, allowing patients to easily view their seizure activity and track changes over time. For healthcare providers, the application could include advanced data analysis tools, enabling them to identify trends.
Okay. Let's make the text way less sensational. And ideally not use any unnecessary terminology. we would like it to be suitable for a university student, including first year. Now, a couple of things. We would like to use open source, publicly available datasets. So if you have any suggestions, that will be great. Yeah, make sure not to use words such as revolution or similar big claims. Also, if we can include the data visualization techniques, that will be great. Yeah, keep generating continuous text paragraphs, avoiding dot points. And don't mind you going into technical details, but keep it light and fun.
Absolutely. Let's refine the text to be more straightforward and suitable for university students, including first year students. We'll focus on explaining the concepts clearly and incorporate suggestions for open source datasets and data visualization techniques. Ultra long term epilepsy monitors. Advancing epilepsy management. Epilepsy is a neurological condition where individuals experience recurrent seizures. Traditional methods for monitoring epilepsy often involve short EEG, electroencephalogram sessions in a clinical setting, typically lasting only a few days. However, recent developments in ultra long term epilepsy monitors, UL teams, offer a new way to manage epilepsy by providing continuous EEG monitoring over months or even years. Ultra long term epilepsy monitors are designed to be implanted under the scalp, where they can continuously record electrical signals from the brain. This continuous monitoring helps healthcare providers detect seizures that may not occur during short clinical visits. By collecting data over extended periods, these monitors provide a more complete picture of a patient's seizure activity, which can lead to better informed treatment plans. One of the primary benefits of UL teams is the ability to create personalized treatment plans. With long-term data, doctors can tailor treatments to fit the specific needs of each patient, potentially improving seizure control and overall quality of life. This personalized approach moves beyond the limitations of one-size-fits-all treatments. Additionally, UL teams can reduce the need for frequent hospital visits. Patients can be monitored continuously from the comfort of their homes, making it more convenient for those who live far from healthcare facilities or have busy schedules. This home-based monitoring can provide peace of mind and a sense of security for patients and their families. The continuous data collected by all teams is also valuable for research. Researchers can analyze this extensive data to better understand seizure patterns and potential triggers. This research can contribute to developing new treatments and improving existing ones. Early detection of seizures is another significant advantage of all teams. By identifying seizures as they happen, doctors can intervene more quickly, adjusting medications or recommending lifestyle changes to manage the condition effectively. Some YEL teams can transmit data remotely to healthcare providers, enabling real-time monitoring and timely adjustments to treatment plans. Improving the quality of life for epilepsy patients is a key goal of all team technology. Continuous and accurate monitoring allows patients to manage their condition more confidently, knowing that they are being closely observed. This can reduce anxiety and improve overall well-being. Developing a web application. To support the use of all teams, we can develop a web application that provides a user-friendly interface for patients and healthcare providers to access and analyze EEG data. Using Flask, an open-source web framework, we can create an application that securely stores and displays this data. The web application should include features such as real-time alerts, data visualization tools, and personalized treatment recommendations. Data visualization techniques like line graphs, heat maps, and interactive dashboards can help users easily understand and analyze their EEG data. For data visualization, libraries such as Matplotlib, Plotly, and D3JS can be integrated into the application. Matplotlib and Plotly are particularly user-friendly and offer a range of plotting options. Interactive features provided by Plotly and D3JS can enhance the user experience, allowing for more dynamic and engaging visualizations. Open source datasets. To develop and test the web application, we can use publicly available datasets. One such dataset is the Temple University Hospital, TUH EEG corpus, which is a large, publicly accessible collection of EEG recordings. Another useful dataset is the CHB MIT Scalp EEG database, which contains EEG recordings from pediatric patients with epilepsy. Using these open source datasets, we can simulate the continuous monitoring provided by YEL teams and develop algorithms to detect seizure patterns. These datasets provide a wealth of information for developing and refining the application, ensuring it is robust and effective. Community engagement. Engaging with the community through platforms like YouTube can be a great way to share progress and gather feedback. Live streaming development sessions, discussing challenges, and demonstrating features can help build a supportive community.
Okay, can we do responses in first person? As if you are co-hosting the channel. Is that acceptable? Is that acceptable? Yeah, we'll be deploying a few things in a second. So this long-term EEG will be a blog first. Okay, it's actually doing it.
Absolutely. Using a first-person perspective can make the content more engaging and personable, especially for live streaming. Let's revise the text to incorporate a conversational tone suitable for co-hosting on a YouTube channel. Hey everyone, welcome back to our channel. Today, we're diving into a fascinating topic that's close to my heart: ultra-long-term epilepsy monitors, or ULTEAMs. If you've ever wondered how continuous brain monitoring can help manage epilepsy, you're in for a treat. Let's break it down together. So, what exactly are ultra-long-term epilepsy monitors? Imagine a tiny device implanted just under the scalp that can continuously record electrical signals from the brain for months or even years. Sounds like science fiction, right? But it's very much a reality. Traditional EEGs, the kind you might get during a short hospital visit, only capture a snapshot of brain activity. ULTEAMs, on the other hand, give us a full movie, showing us everything that happens over long periods. This continuous monitoring is a game changer for a few reasons. First off, It helps doctors detect seizures that might not show up during a short EEG session. This means they get a much clearer picture of how often seizures occur and what might be triggering them. With all this extra data, doctors can create treatment plans that are personalized to each patient. It's like having a tailor-made suit instead of one off the rack. Another cool thing about UL teams is that they can reduce the need for frequent trips to the hospital. Patients can be monitored right from their homes, which is super convenient, especially if you live far away from a medical center. Plus, it gives peace of mind knowing that your brain activity is being watched continuously. Now, here's where it gets really exciting. All this data collected by UL teams can help researchers understand epilepsy better. By analyzing these massive data sets, we can find patterns and triggers that were previously hidden. This could lead to new treatments and better management strategies. Early detection of seizures is another huge benefit. If a seizure is detected early, doctors can adjust medications or suggest lifestyle changes to help manage the condition more effectively. Some UL teams can even send data remotely to your healthcare provider, so they can keep an eye on things in real time. Improving the quality of life for people with epilepsy is the ultimate goal here. Continuous monitoring allows patients to manage their condition more confidently. Knowing that you're being closely observed can really help reduce anxiety and improve overall well-being. All right, let's switch gears and talk about how we can support these monitors with a web application. Using Flask, an awesome open source web framework, we can create an app that securely stores and displays EEG data. Picture a dashboard where you can see real-time alerts, visualize your data, and get personalized treatment recommendations. For data visualization, we can use libraries like Matplotlib, Plotly, and D3JS. These tools can help us create interactive and dynamic graphs that make it easy to understand brain activity. Imagine seeing your brain waves in real time or tracking changes over weeks and months. It's not just useful, it's pretty cool to look at too. And here's where you come in, engaging with all of you through live streams on YouTube. We'll show you the development process, discuss technical challenges, and demonstrate the features of our web app. Your feedback and suggestions will be invaluable as we refine and improve the application. To make all this happen, we'll use open source datasets like the Temple University Hospital TUH EEG corpus and the CHBMIT Scalp EEG database. These collections of EEG recordings will help us simulate continuous monitoring and develop algorithms to detect seizure patterns. In summary, ultra-long-term epilepsy monitors are set to make a big impact on epilepsy management. By developing a web app to support these monitors, we can enhance their usability and provide real-time data access and personalized treatment plans. Your support and engagement will be key in making this project a success. Thanks for joining me today. If you have any questions or thoughts, drop them in the comments below. Don't forget to like and subscribe for more exciting content. See you next time. I hope this captures the...
Okay, yeah, it's doing first person. Next thing it will be. When are you gonna be hosting my YouTube channel instead of myself? What? Okay, that's hallucinating a bit. Now I got confused by that. Yeah. So a human is still necessary in the loop, but probably not for long. Are you changing this? Control I. I was asking to change into HTML. Okay, why don't you do it? Change this text into HTML script. What? Ah. It's changed it into. Okay, that's actually interesting. What the earth? Uh, what did it do? No idea. I have no idea what just happened. Okay, so we have that title. That's fine. Might have to bring all that back because there's some sort of weird copy pasting error thingy. Why is it refusing to? Is there a recent update or something? Just write HTML. Yeah, it's doing it now. Shorter prompts. Is that what the problem is? Yeah, we finished that. A Copilot is keen to write a conclusion. What? What's it placing? It's just using whatever in another document. Just placing a link there. Didn't really ask for it. Finish. Finish the page. And here, what? Okay, if you must. Right. Yeah, this is better. It's also placed. We'll give an error with it. Do they need? I think they might. Yeah, fuzzy logic is a Flask application, so we might need the. Yep. We actually, yeah, I don't know what's writing a copy left. We actually we have it as an open source. Turn into open source. Yeah, that's also not absolutely accurate because we actually have all the source code on the website itself. I'm not actually sure about copyright. I think we're using CC for right. It's actually included that image. That's nice. Creative Commons. Took the PNG. Probably don't need this. Break. Is this link working? Yes. Does this need to be my license? We actually don't mind commercial. Yeah, it doesn't really matter. We don't like bureaucracy as well, so why is that a link? Don't need that as a footer. I don't know what difference does it make anyway. We would like. Hey, can you fix the code? We don't have that class. Why so many? Can we do this? Why is there still a link? Yeah, I'll leave it at that. That's the maximum of time I'm happy to spend on bureaucracy. That's pretty much it. Okay, developing the application. Okay, forget. Hey, let's actually start a new chat quickly. Okay, can you repeat this text above? I'll just repeat the text above and start again. We'll actually listen this time.
Certainly. Here's a summary of the text. Ultra long-term epilepsy monitors, advancing epilepsy management. Epilepsy is a neurological disorder characterized by recurrent seizures. Traditional monitoring methods often involve short EEG sessions conducted in clinical settings, which typically last only a few days. However, recent advances in ultra long term epilepsy monitors, UL teams, offer a new approach to managing epilepsy by providing continuous EEG monitoring over extended periods, ranging from months to years. UL teams are implanted under the scalp and continuously record brain electrical activity. This long term monitoring helps healthcare providers detect seizures that might not occur during brief clinical visits. The extensive data collected enables a more comprehensive view of a patient's seizure activity, leading to more informed treatment plans. One key advantage of UL teams is the ability to create personalized treatment plans. Long-term data allows doctors to customize treatments based on each patient's specific needs, potentially enhancing seizure control and improving quality of life. This personalized approach moves beyond the limitations of generic treatments. Moreover, UL teams reduce the need for frequent hospital visits as patients can be monitored continuously from home. This convenience benefits those living far from healthcare facilities or with busy schedules. Home-based monitoring provides peace of mind for patients and their families. The continuous data from UL teams is also valuable for research. Researchers can analyze extensive data sets to better understand seizure patterns and triggers, contributing to the development of new treatments and the improvement of existing ones. Another significant benefit of UL teams is early seizure detection. By identifying seizures in real time, doctors can promptly adjust medications or suggest lifestyle changes, leading to more effective condition management. Some UL teams can transmit data remotely, enabling real-time monitoring and timely treatment adjustments. Improving quality of life is a primary goal of UL team technology. Continuous and accurate monitoring helps patients manage their condition with greater confidence, reducing anxiety and enhancing overall well-being. Developing a web application. To support UL team usage, a web application can be developed to provide a user-friendly interface for accessing and analyzing EEG data. Using Flask, an open-source web framework, the application can securely store and display this data. Key features of the web application should include real-time alerts, data visualization tools, and personalized treatment recommendations. Data visualization techniques like line graphs, heat maps, and interactive dashboards can facilitate understanding and analysis of EEG data. Libraries such as Matplotlib, Plotly, and D3.js can be integrated for data visualization. Matplotlib and Plotly offer user-friendly plotting options, while Plotly and D3.js provide interactive features for enhanced user experience. Open source datasets. To develop and test the web application, publicly available datasets can be used. The Temple University Hospital TUH EEG corpus is a large, publicly accessible collection of EEG recordings. The CHB MIT Scalp EEG database, containing EEG recordings from pediatric epilepsy patients, is also useful. These open-source datasets allow simulation of the continuous monitoring provided by UL teams and aid in developing algorithms for seizure detection. They offer valuable information for creating a robust and effective application.
Okay, that sounds good. Just final few improvements. First of all, I don't think we need any acronyms. So if you can remove them, that will be great. Now, regarding the web application, this will be targeting a researcher. It is less for the patient. I mean, if the patient is keen on the technical details, that's fine. But we won't be doing real-time alerts or anything like that. We will be focusing on visualization of the data. Finally, if you can give a bit more overview on the open source datasets, that will be great.
Sure, here's the revised text with those adjustments. Ultra long term epilepsy monitors, advancing epilepsy management. Epilepsy is a neurological condition characterized by recurrent seizures. Traditional methods for monitoring epilepsy typically involve short EEG sessions conducted in clinical settings, usually lasting only a few days. Recent advancements in ultra long term epilepsy monitors offer a new approach by providing continuous EEG monitoring over extended periods, such as months or years. These long term monitors are implanted under the scalp and continuously record electrical activity from the brain. Continuous monitoring enables healthcare providers to detect seizures that may not occur during brief clinical visits. The extensive data collected provides a more comprehensive view of a patient's seizure activity, allowing for better informed treatment plans. One major benefit of long term epilepsy monitors is the ability to create personalized treatment plans. With long term data, doctors can tailor treatments to fit the specific needs of each patient, potentially enhancing seizure control and overall quality of life. This personalized approach moves beyond generic treatment plans. Additionally, these monitors reduce the need for frequent hospital visits, as patients can be monitored continuously from their homes. This convenience is particularly beneficial for those living far from healthcare facilities or with busy schedules. Home-based monitoring offers peace of mind for both patients and their families. The continuous data from these monitors is also valuable for research. Researchers can analyze this extensive data to gain insights into seizure patterns and triggers, which can contribute to developing new treatments and improving existing ones. Early detection of seizures is another significant advantage. By identifying seizures as they occur, doctors can intervene more quickly, adjusting medications or suggesting lifestyle changes to manage the condition more effectively. Some monitors can transmit data remotely, allowing real-time monitoring and timely treatment adjustments. Improving quality of life for patients is a key goal of this technology. Continuous and accurate monitoring helps patients manage their condition with greater confidence, reducing anxiety and enhancing overall well-being. Developing a web application for researchers. To support the use of long-term epilepsy monitors, a web application can be developed specifically for researchers. This application will focus on providing a user-friendly interface for accessing and analyzing EEG data. Using Flask, an open-source web framework, the application will securely store and display the data. The web application should include features like advanced data visualization tools and the capability to generate personalized treatment insights based on the data. Visualization techniques such as line graphs, heat maps, and interactive dashboards will help researchers easily understand and analyze EEG data. Libraries such as Matplotlib, Plotly, and D3.js can be used for data visualization. Matplotlib and Plotly offer user-friendly plotting options, while Plotly and D3.js provide interactive features to enhance the user experience. Overview of open-source datasets. To develop and test the web application, publicly available datasets will be crucial. One valuable dataset is the Temple University Hospital EEG corpus, which is a large collection of EEG recordings available to the public. Another useful resource is the CHB MIT Scalp EEG database, which contains EEG recordings from pediatric patients with epilepsy. The Temple University Hospital EEG corpus provides a broad range of EEG recordings that can simulate the continuous monitoring provided by long-term epilepsy monitors. It is useful for developing and refining algorithms for seizure detection and analysis. The CHB MIT Scalp EEG database is particularly valuable for its focus on pediatric patients, offering insights into seizure patterns and responses in a younger population. Both datasets are essential for creating a robust and effective web application for researchers, enabling them to test and validate their algorithms and approaches using real-world data.
Okay, can you turn it into one paragraph, continuous text, but make it more fun?
Certainly. Here's a more engaging version in a single paragraph. Epilepsy is a condition where seizures repeatedly disrupt a person's life, and while traditional methods involve short EEG sessions in clinical settings, a groundbreaking approach is emerging with ultra long term epilepsy monitors. These innovative devices, implanted under the scalp, continuously track brain activity for months or even years, offering an unprecedented look at seizure patterns. By collecting this extensive data, healthcare providers can craft highly personalized treatment plans, improving seizure control and quality of life. These monitors also mean fewer hospital visits since patients can be observed from the comfort of home, making life a bit easier for those living far from healthcare centers. On the research front, the endless stream of data is a goldmine for understanding seizure patterns and triggers, paving the way for new treatments and advancements. To support this exciting field, a web application is being developed specifically for researchers. Using Flask, the app will offer a sleek interface for diving into EEG data, with powerful visualization tools like line graphs and interactive dashboards to make complex data accessible and engaging. By leveraging open source datasets such as the Temple University Hospital EEG corpus and the CHB MIT Scalp EEG database, the app will simulate real world monitoring and fine tune algorithms for seizure detection. These datasets provide a rich resource for developing robust solutions and advancing research in epilepsy management, turning complex data into actionable insights for a brighter future.
Okay, can you include continuous paragraph on what specific visualization techniques could be used? Keep it technical, but yet fun.
Absolutely. Here's a continuous paragraph that combines technical detail with a bit of flair. To make sense of the rich data from ultra long term epilepsy monitors, our web application will employ a variety of advanced visualization techniques. Imagine diving into line graphs that track EEG activity over time, offering a clear view of how seizures unfold and evolve. Heat maps will transform complex data into colorful, intuitive patterns, highlighting seizure hotspots and patterns with vibrant clarity. Interactive dashboards will allow researchers to explore data dynamically, zooming in on specific timeframes or adjusting parameters to uncover hidden insights. For a more detailed analysis, we'll use time frequency plots to reveal how brain activity changes across different frequencies, shedding light on subtle shifts that might indicate an impending seizure. Additionally, 3D plots and animation tools can offer a multi-dimensional perspective, making it easier to visualize intricate relationships between various data points. By blending these technical visualizations with an engaging interface, we aim to turn data exploration into a compelling experience, helping researchers unlock new insights and advance epilepsy management.
Can you rewrite the information about the open source datasets?
Certainly. Here's a revised version of the information about the open source datasets. To develop and test our web application, we'll harness the power of open source datasets, which provide invaluable real world data for refining our tools. The Temple University Hospital EEG corpus is a treasure trove of EEG recordings, offering a diverse collection of data that mirrors the continuous monitoring seen with long term epilepsy devices. This dataset allows us to simulate real world conditions and develop sophisticated algorithms for detecting and analyzing seizure patterns. Complementing this is the CHB MIT Scalp EEG database, which is especially useful for its focus on pediatric patients. This dataset provides detailed EEG recordings from younger individuals with epilepsy, offering unique insights into seizure dynamics and responses in a younger population. By leveraging these datasets, we can rigorously test our application, ensuring it's robust and effective in delivering accurate and insightful data visualizations for researchers. Certainly. Here's a more detailed explanation of how the open source datasets can be used in developing and testing the web application. To develop and test the web application effectively, we will utilize two key open source datasets, the Temple University Hospital EEG corpus and the CHB MIT Scalp EEG database. The Temple University Hospital EEG corpus is a comprehensive collection of EEG recordings that provides a diverse array of data from various patients. This dataset includes recordings from multiple channels, capturing detailed brain activity over extended periods. We can use this dataset to simulate the continuous monitoring capabilities of long-term epilepsy monitors. By integrating this data into our application, we can develop and test algorithms for detecting and analyzing seizure patterns across different patients and conditions. The dataset's breadth allows us to explore variations in seizure types, frequency, and duration, ensuring that our application can handle a wide range of real-world scenarios. Visualization techniques such as line graphs, heat maps, and time frequency plots can be applied to this data to uncover and present seizure patterns effectively. The CHB MIT Scalp EEG database focuses on EEG recordings from pediatric patients with epilepsy. This dataset includes high-resolution EEG data captured from young individuals, providing insights into the unique seizure characteristics and brain activity patterns in this age group. By using this dataset, we can tailor our visualization tools to address the specific needs and conditions of pediatric epilepsy. For example, we can analyze age-related variations in seizure patterns and brain activity, helping researchers understand how seizures may present differently in children compared to adults. The data from this dataset will also be useful for refining our algorithms to ensure they are accurate and reliable across different patient demographics. In summary, both datasets are crucial for developing a robust web application. The Temple University Hospital EEG corpus allows us to simulate real-world continuous monitoring and test a wide range of seizure patterns, while the CHB MIT Scalp EEG database provides specific insights into pediatric epilepsy. Together, these datasets will help us create a comprehensive and effective tool for visualizing and analyzing EEG data, supporting researchers in their efforts to understand and manage epilepsy more effectively. Certainly. Here's a fun and engaging conclusion for the blog. In the world of epilepsy management, ultra-long-term monitors are like having a supercharged detective on your side, continuously keeping an eye out for every clue in the brain's activity log. These monitors bring a new dimension to understanding seizures, offering a panoramic view that traditional methods simply can't match. By harnessing the power of continuous EEG data, researchers can dive deep into the mystery of seizure patterns, much like a detective unraveling a complex case with a treasure trove of evidence. Our web application is designed to be the ultimate toolkit for these modern-day sleuths. By integrating advanced visualization techniques and leveraging invaluable open source datasets, we're turning raw data into a treasure map of insights. The Temple University Hospital EEG corpus and the CHB MIT Scalp EEG database are our key allies, providing the clues and context needed to solve the intricate puzzle of epilepsy. With these resources, we're not just visualizing data, we're crafting a dynamic, interactive experience that transforms complex information into clear, actionable insights. As we continue to innovate and explore, we're making epilepsy management not just more effective, but also more engaging. So, whether you're a researcher looking to decode the secrets of seizure activity, or simply curious about how technology is reshaping healthcare, Our journey into the world of ultra long term monitoring and data visualization promises to be as thrilling as a detective novel with a twist of high tech excitement. Certainly. Here's a detailed summary of the entire blog using engineering analogies. In the realm of epilepsy management, ultra long term epilepsy monitors are like state of the art engineering sensors designed to capture and analyze data with unparalleled precision. Just as engineers use advanced sensors to monitor and optimize the performance of complex systems, these monitors provide a continuous stream of brain activity data, enabling a more thorough analysis of seizures over extended periods. Traditional epilepsy monitoring methods resemble outdated machinery that provides only intermittent snapshots of performance. Imagine relying on a single brief inspection to understand the behavior of a high tech piece of equipment. It's simply not enough. In contrast, ultra long term monitors function like sophisticated diagnostic tools that continuously track performance, allowing for a comprehensive understanding of how and when issues arise. By implanting these monitors under the scalp, researchers and healthcare providers gain a detailed real time view of brain activity, akin to having a full telemetry system that provides ongoing feedback from a high performance engine. The web application we're developing is similar to a high tech control panel that engineers use to interpret sensor data and make real time adjustments. This application will feature advanced visualization tools. Think of them as sophisticated dashboards that turn raw data into actionable insights. Line graphs will be like performance curves showing how the system behaves over time. Heat maps will act like thermal imaging, revealing hotspots of activity. And interactive dashboards will function like dynamic control panels, allowing users to zoom in on specific data points and adjust parameters for deeper analysis. To build and refine this application, we're leveraging open source datasets, which are like high quality blueprints for engineers. The Temple University Hospital EEG corpus is our detailed schematic, providing a comprehensive array of EEG recordings that help us simulate continuous monitoring and test our algorithms as if we were fine-tuning a complex machine. Similarly, the CHB MIT Scalp EEG database serves as our specific technical manual for pediatric cases, offering detailed insights into the unique characteristics of seizures in younger patients, much like specialized documentation for optimizing equipment used in specific conditions. In summary, just as engineers rely on precise measurements and advanced tools to ensure their systems operate optimally, ultra long term epilepsy monitors and our web application work together to provide a detailed, continuous understanding of seizure activity. By using these advanced techniques and leveraging valuable data sets, we are turning the challenge of epilepsy management into a well engineered solution, paving the way for more effective research and improved patient care.
It's a Python script that's actually testing the website. Using beautiful soup. A screen scraper's friend. For fetching the description. Anyway, it's generating this XML. Yeah, so we have 13 pages that we need to look at because they have two little text. The description is too short, like this one. Yeah, the description is not great. Shall we jump into it? Yeah, we'll actually like a video as well of me using it. From memory, there was a problem with this one. Yes, this one is using Plotly, but it was displaying the page as such on loading. It does one thing and then changes. So I assume that would be the CSS styling that kicks in. Like a second later, we can actually check if F12 network. Yeah, restart the page. Yes, it's loading there. It takes forever to load. So why there's so much stuff to it. We have to test it in locally in development because there could be some things are not relevant. Some things will be to do the third parties. There's a GIF. I assume it's part of the ad, part of the advertisement. Yes, so removing third-party requests doesn't remove the Google stuff still. That's unusual. Yeah, anyway, we'll have to test the locally. Should we do it right now? Yeah, we had a similar tool on the page. Looks like that, but doesn't have the extra functionality. So there's the EG view. It's the same data, I'm pretty sure. So eventually this one will go. Yeah, there's a couple of good options there, which I would like to keep. Can split by left and right. Overlay. Or decide the separation value on the chart, so that's pretty handy. We don't have much text in coherence. All the pages now in terms of the ads, there will be no ads. Well, hopefully we'll see how we go. Overlaid on the, the first time you load the page. There might be that annoying thing. Yeah, that shows you some relevant links and stuff. This is added by Google. It's not part of the website. Okay, this one doesn't work at all. Shoot, bro. Data is not available. Okay, stop that. Data is not available. Why don't I see it? The data is not there. Can actually fix this. I'm pretty sure this will be working in production. Okay, let's actually find that gate analysis. Should be an easy fix. Okay, if we run it locally, ooh, the data is still not there. I was sure it will run locally. Okay. Meant to be normal gate JSON in the data folder. I do see it. What's the problem? Okay, I know what the problem is. What? Why is it complaining? Yeah, this should be an easy fix for a Copilot. I'm not sure. When you have workspace handle, so the file path that okay, now it's working. But question, will it work in production as well? By the way, yeah, from memory, these two meant to look like footsteps showing pressure on them. We need to check if the thing is running locally or not. That will be happening in JavaScript. Yeah, we need to check like this. What happens handle do we use? Explain terminal. No. Workspace. Maybe. Okay, we need to apply it for this code. Okay, we have this. But we also wanna add that line. Can you do this for us? Okay, it's misunderstood. What is it we are trying to do? We need to integrate a check if we're in production local environment. And set appropriate and set the appropriate endpoint URL. Can you do this? Okay, this should just be gate analysis. Like that. I think so. What's the problem? The folder is right there. Sure what the problem is. Some silly mistake. Can we just provide this image to the bot, see if it's able to pick up on the error? Python. We don't have send from directory. This is what we currently have for the Python code. Okay, that's working locally. In theory, it should work in production as well. Let's deploy. Let's deploy. Okay, might need to clear. We might need to clear the cache. Take a second, bear with me. Okay, so we're still having a problem where so we have this Python code and we have this script.js. So we have this code, a Python code for the backend of the Flask application and the front end JavaScript. It is working locally. However, I'm getting errors in production. It seemed to still trying to access the wrong folders. I sent it by mistake. The JavaScript. Okay, that's actually different. And Python. Haven't changed. Just added one character. That could be the solution, could it? It's trying to access the wrong folder. Why on earth am I not able to edit a prompt that has an image? Should really be accessing that. What? That looks wrong. That's wrong. Let's try the legacy GPT-4. Okay, this is better. Yes, this is the same. And this is the same as well. So what the problem? Have 99 lines of code. What did you remove? That's weird. Okay, this is not fun. Do we only have? Yeah, we only have one JavaScript. Yeah, we're still trying to access the wrong folder. Very unusual. We check the script was actually updated. That's the wrong script. Ah, okay, the script is missing. That's to do the HTML files now. Isn't there an error for that? Okay, we have a oh, this is a problem, isn't it? Okay, we actually needed that script. Okay, we want this to want to check if this is happening in production. Okay, we want to actually use this JavaScript instead. But we would also like to integrate the following check for production or not. Okay, so the rest of the code should be the same. Endpoint should be used, yes. We are calling it in the HTML, so let's check it. Check it locally. Should be scripts. Right, so it's working locally. Let's check in production as well. There's some edge cases. Edge cases issue that is still fine. Hey, can you in text alone, using continuous paragraphs, explain this application and give it a general overview as well, and also include the technical details? If you can make it fun somehow, that will be great.
This application, a captivating blend of data visualization and interactive exploration, dives deep into the fascinating world of gait analysis. Gait analysis, the study of human walking patterns, has significant implications in biomechanics, clinical assessments, and even sports science. Our application provides an engaging way to visualize and compare normal and abnormal gait patterns, making it not only a powerful tool for researchers, but also an intriguing experience for anyone curious about the mechanics of walking. When you load the application, you are greeted with two primary visual components: the normal heat map and the abnormal heat map. These heat maps are dynamic SVGs, scalable vector graphics, that visually represent the pressure distribution on a foot during different phases of walking. As the name suggests, one heat map showcases a typical walking pattern, while the other highlights deviations from the norm, which could indicate issues or unique characteristics in an individual's gait. The fun begins with the playback controls. Imagine being a DJ, but instead of mixing music, you're mixing data. There's a big play button that lets you start or pause the animation, allowing you to see how pressure points move and change over time as someone walks. The accompanying time slider lets you scrub through the data at your own pace. Want to see that peculiar step again? Just slide back and forth to replay the moments of interest. Under the hood, the application is powered by a robust combination of technologies. It uses D3.js, a JavaScript library for producing dynamic, interactive data visualizations in web browsers. D3.js brings the heat maps to life, scaling and coloring the data points based on their pressure values, making the complex data intuitively understandable. The application also includes a smart way to handle different environments. Whether you are running it locally on your machine or it's deployed on a remote server, the app knows where to fetch the data from. It differentiates between a local environment and a production environment using a simple yet effective check on the host name. This ensures that no matter where the app is running, it seamlessly pulls in the correct gait data for visualization. Speaking of data, the application fetches its data from JSON files stored on the server. When you click play or move the slider, it fetches the relevant data for that specific time frame and updates the heat maps accordingly. This keeps the user interface responsive and ensures that you are always looking at the most relevant data slice. Behind the scenes, a Flask application runs the show. Flask, a lightweight web framework for Python, handles the data requests and serves the necessary files. When you request data for a specific gate type, be it normal or abnormal, Flask reads the corresponding JSON file, parses the data, and sends it back to the client in a structured format. This interaction between the client-side JavaScript and the server-side Flask application makes the whole experience smooth and efficient. In essence, this application is a beautiful marriage of science and technology, wrapped in an interactive package that invites users to explore the nuances of human gait. It's like having a window into the biomechanics of walking, allowing you to see how every step unfolds in vibrant detail. Whether you're a researcher looking for patterns, a clinician assessing a patient's progress, or just someone fascinated by the mechanics of movement, this application offers a delightful and insightful journey into the world of gait analysis. So go ahead, hit play, and take a step into the data-driven future of walking. Step into the fascinating world of gait analysis with our dynamic and interactive web application. This engaging tool brings the science of walking patterns to life, showcasing vibrant heat maps that visualize the pressure distribution on feet during normal and abnormal gait cycles. With intuitive playback controls and a responsive interface, you can explore every step in mesmerizing detail. Powered by D3.js for stunning visuals and Flask for smooth data handling, our application makes the biomechanics of walking both insightful and fun. So hit play and discover the intricate dance of human movement like never before.
Stop playing. Yeah, the button meant to be taken over. Can we somehow check the button functionality? It used to be different. Can you look it up in the conversation above? See if it can find it. I'm pretty sure it's changed it. Okay, the play button starts in a pause state, which means the animation is playing by default. What? That doesn't make sense. Okay, what happens when the user clicks on the slider and starting to use it? What happens to the play button? Well, it should be turned off. Okay, it should not. Can you look at the original code? Provided in the beginning of this conversation. I wonder if it can go back and forth through the code like that. Okay. Provided clarify the behavior of the play button and slider interactions. When the user interacts with the slider, it pauses the playback and updates the hitmap based on the slider position. This way, the play button will accurately reflect the pause state. Okay, so that's in a JavaScript. It's just rewriting the whole thing though. We currently have 105 lines of stuff. Okay, then it's back to still checking endpoint correctly. Yes. Let's test it straight away in production. Okay, there's a problem. I stuffed something up, didn't you? Oh, something isn't working correctly. Here is the current JavaScript code that we have at the moment. Let's see what it can do. Right, bringing back some stuff. This looks more promising. I expect it to be 105 lines. It's like 112. Okay, this is better than less than 105. Okay, shall we check it on the server? Yes. Okay, it's working okay on the server. Let's check in production. Okay. Yep, so the functionality of the play button. Also, could you indicate how to make the automated scrolling when the play button is pressed a bit faster? Can we make it faster? Yeah, and when you touch the slider, it will. Find the set interval. What we have? Check that it's not too fast or anything. Yeah, it's okay. Double the speed is fine. Yeah, the background is a bit annoying, but it's not why the labels are on top like that. Do we have? Where's our CSS? Should have a CSS as well. Can we generate a CSS code in a separate file? quickly go over what we have so far. So we have this gate application that meant to look like steps. So obviously should have some images for this thing. Yeah, it meant to look like this. Yeah, two sets of feet, this type of view, and we're meant to have a heat map when, as if modeling, as if the person is walking, and one should have normal gait, the other one is abnormal, and you should be able to scroll through it. And so far we have this. So obviously this will need more work. We have a whole blog article about the ultra long-term EEG monitoring. Mention EEG. Yes, it should have been in the title as well. And we potentially will be looking at this open source datasets and making a web application with that data. What else we've got? Yeah, another blog. Why is it called NeuroGPT? Good question. We'll come back to this one. Yeah, fuzzy logic. Yeah, this one should be working okay. We could use more data points in there now that it's working. Don't actually need the generate signal button, and those overlay tip things don't actually work. There is a detailed overview, so go check it out. Let me know what changes need to be made. Let's go quickly back to the here. Privacy. The privacy page is too short. No, I don't think so. we actually, yeah, we needed it for some other reasons. So we'll close it for now. I think the ECOG is actually using one of those data sets already. Ooh. Messy, messy, messy. Yeah, we actually got rid of the we got rid of the data. Don't have anything in the HTML. What? No, we do. So what's the problem? They run the Flask application. Yeah, that's ugly. But at least it's doing something. So that means the Flask application is not actually being deployed. Yeah, there's something wrong. Multitask analysis. Yeah, we can close it. So that's ECOG. Yeah, cardio quest is working okay. We might pop a link to an updated version of this tool. Let's do it straight away, shall we? Let's do it straight away. But the ECOG will need way more work. Might open it in a new window. Yeah, we haven't touched it in a while. But still, I have a feeling, yeah, I have a feeling something is running. Quickly in cardio quest. We have a description and everything. Is it even true? Wait, so it's that. That's correct. 10 points. Incorrectly tagging a normal ECG like this. Let's give it -10. What you talking about? That's wrong. Anyway, yeah, it's wrong because we don't have the code for this. And we could have the code. We don't do yeah, we kind of stopped using GitHub. Well, first because it's Microsoft. Second, because we don't want to divert traffic away from this website. So stick around. We do actual code goes here. Yeah, what don't you understand? Actual script of the code goes here. What are you doing now? It's text. So GitHub is so ingrained that you can't get rid of it. A check a more advanced version of the game. Is it? No. What? What are you getting random links for? This one. A cardio bot. Yeah, for more advanced version of the game, check out. That's right. Let's check this section working. Yes. That is working okay. And we could happily include the code for the game. We'll go on. There is a video. No, wait, that's a different one, is it? Yeah, Kanye West is the earlier version of the thing. Kanye Quest. Okay, what do we need? What do we need? We should gonna populate. No. Is it even correct? Okay, there's more. There is more. Okay, we have the JavaScript. Yeah, it's all JavaScript. Yeah, we have the waveforms and the game logic should be fairly simple. Yeah, we had stuff like that. The waveforms first. Yep, it's pulling out stuff already. Okay. We have the code. Like a text. Yeah, I'll just pop in the code, pop in the code. Just break it slightly. Pop an add in between. Why do we need the git ignore file? Okay, can we generate all the necessary code? We are not using virtual environments. We're running everything globally. Okay, when the file is uploaded, do we check or the file contents? How do we actually know it's an image and not the virus or something? Okay, in the first stage, we'll have an image folder in the static directory, so the user can select from a predetermined list of images. Can we start with using images from the following folder? flask. Okay, so the puzzle is doing something. You can't move the pieces. There must be a placeholder. Somewhere in the code. Which part is responsible for moving the pieces around? Yeah, did not include that functionality to update the JavaScript. We can move them around. And to be EEG, isn't it? Could be EEG alone. That will be Must be a corner piece, isn't it? Maybe have fun with this. Ah, yeah, good luck. Then we need to make sure it's actually working okay. Like a mobile size. No. Any chance we can make it work okay on a mobile as well? Okay, so this is just something fun to finish with. This puzzle. Let me know. There's no currently option to upload an image. Maybe. Hey, can we just, when the page loads the first time around, just select and generate a random puzzle on page load? Yes, it's selecting random. Well, you know what I mean by random. It looks random. You don't want to face a mathematician and tell them something is random. They'll be arguing with you for hours. Not always generating. Um, poo, poo, poo. For some reason, it's not always generating the whole thing on a single button press. Sometimes two button clicks are required to actually load the whole image puzzle. Can you check why that might be asynchronous nature of the image loading. Okay. Yeah, the image I think takes some time to load. I don't know if they're too large or something. Yeah, this actually works better. Yeah, we have the yeah, there's another issue. Maybe it won't be actually an issue when deployed. Don't know. But the mouse, yeah, should be simple stuff, isn't it? Anyhow, we'll publish this quickly as well. We don't get an extra error. Yeah, for this one being empty. Don't like empty pages, do we? We don't like empty pages. So we have descriptions and everything. Yeah, we need all this. Why doesn't GitHub Copilot want to generate or not? What's wrong? We have the description and title and everything. What's the problem? It's still generating. Is there something wrong with Copilot? shapes meant to be irregular. Yeah, we were prompting it before. It couldn't really do it. We might need to open it in the new window. Right, now it's working. That's weird. Yeah, GitHub Copilot. Okay, so let's finish it over here. That's fine. It's highly sensitive on what else is running, like what other files are open, because it's looking at them. Well, sometimes. And yes, the website has ads on it. Hopefully they're not too distracting. Are we ready to deploy? Not sure. Wait, do we have it? No, that's yeah, those errors are okay. Those errors should go away when in production. We should wait a sec. One thing. This is a Flask application, isn't it? This is a Flask application. So we actually have to change some settings. Yeah, we don't have a puzzle. Hey, we need enough file in it. Let's do it quickly. We have to do it quickly. Need a file like that, the my.app.wsgi. This need to change it. It's not Vision Sim, it's puzzle. And we also need an entry in configuration file for the server. We essentially need a copy like that. Instead of EG view, everything needs to be called puzzle, puzzle, puzzle. Only giving it 2 threads on the server. We need to check Apache server. A configuration test syntax is okay. Let's deploy. Fingers crossed. We get a server error. What? That's not nice. Still. Might have to purge caching on the CDN. Yeah, don't ask. Okay, I think I know what the problem might be. It's actually, is it still running locally? Well, it's not running. I mean, it's still working locally. Yes. Script. Let's check that. Should be. JavaScript. Yeah, probably have to check. Oops. Let's run that. This is checking the whole website thingy. Okay, we'll have to probably troubleshoot this next time. I think I know what the problem might be. We might need to check if they are running locally or not. Do we have any JavaScripts? We need to modify the JavaScript to check if the application is running on a local server or in production, similar to this. And we would like to integrate it into the JavaScript code that we currently have. Let's see, we're using 4.0 logic to determine the application running in blah blah. Set appropriate endpoint. Okay. Is production. Um, do we have generate? Yeah, fetch. We should be able to fix it ourselves. That should be puzzle. We should not have fuzzy. And that didn't solve it. Can you? Yeah, how about this? Why are we loading all the images? It's a bit weird. Shouldn't be the case. No, that's working okay locally. The application is running okay locally. There are no errors. I only get this in production. Yeah, that's actually solved that. So GPT-4, yeah, it's pretty amazing. Yes, we can regenerate the puzzle this way. If you refresh the page, it will give you a random one, and then you can select a different one as well, and do puzzles if you like. Just one last thing. we might finish now. Hopefully you have any questions and you have checked the website. Let me know if you did. If you have any comments, complaints, like too many ads or anything like that, I'll happily address them during future live streams. Bye.